Good morning, grade 10. Hope you are doing well. This is Mrs. Pascale. Today's lesson is chapter 10, section 10.2, Radical Expressions, part 4. The objective is to simplify radical expressions in multiplication and in division. First, we'll start by correcting the previous homework. In number 1, radical 6 times radical 30. We need to multiply 6 by 30. It gives radical of 180. Then, using the prime decomposition of the value 180, we get a radical of 2 square times 3 square times 5. Reducing this writing, we get 2 times 3 radical 5, or you can directly write 6 radical 5. In number 2, 2 radical 3 times radical 96. It's since we need to multiply the radical with the radical and the integer with the integer, so we can directly write 2 radical of 288. Writing the prime decomposition of 288, we get 2 radical 2 to the power 5 times 3 square. Okay, since we need to reduce this writing, we should decompose the exponent 5 into 2 to the power 1 times 2 to the power 4 in order to reduce the radical. And finally, we get the integer 2, then 2 square obtained from the square root of 2 to the power 4 and 3 obtained from the square root of 3 to the power of 2 and multiplied by radical 2. Calculating or reducing this answer, we get 24 radical 2. In number 3, radical 5 times radical 70 gives radical 350. Writing the prime decomposition of 350, we get radical 2 times 5 times 5 squared times 7. Reducing the square root of 5 squared, we get 5 radical 14. In number 4, minus 4 radical 7 multiplied by radical 42 gives minus 4 square root or radical of 294. Writing the prime decomposition of this number, we get minus 4 square root of 2 times 3 times 7 square. So only square root of 7 square can be reduced. It gives minus 4 times 7 square root of 2 times 3, which is minus 28 radical 6. Square root of 4a times square root of 12a5. We need to multiply first the radicand, so we get radical of 48a6. Writing the prime factorization of 48, we get square root of 3 times 2 to the power 4 a to the power 6. So 2 to the power 4 and 8 to the power 6 can be reduced. We get 2 square a3 square root of 3, which is 4a cubed square root of 3. The final question or expression, square root of 2n squared times square root of 30n gives radical of 60n cubed. Writing the decomposition of 60 gives 2 squared times 3 times 5. Since n is with odd exponent, we need to write it into product of even exponent with exponent 1. So we need to write n squared times n to the power of 1. Reducing this expression gives 2 times n, and the remaining will be radical 15n. Now let's move to learn how can we divide the square root. for any two numbers, any positive for sure two numbers. Since we need to work with division, so the denominator in the fraction should be a non-zero positive number. That's why the rule states that for a greater or equal to 0 and b greater than 0, we have square root of a over b gives square root of a over square root of b. It's the same concept as in multiplication. So if we have two radicals, we can write it into one radical over a fraction and vice versa. Examples. To simplify the following fractions, first, we have radical of 64 over 49. We can write it square root of 64 over square root of 49 as states the property. Then, since 64 is a perfect square of 8, and so we can directly write 8, or you can use the prime decomposition in order to get 8. But it's easier for you to memorize the perfect squares of numbers. It's given in the first part in this lesson. And the square root of 49 gives 7, since 49 is the perfect square of 7. So the final answer is 8 over 7. In example 2, square root of 9 over 144 gives square root of 9 over square root of 144. Since 9 is the perfect square of 3, we can directly write the reduced answer of the radical. It's a 3, and since 144 is the perfect square of 12, so we can directly write the answer of radical 144 is 12. Since we are working with fractions, so any fraction should be given in its irreducible form. So we can finally divide the fraction or simplify the fraction by 3 to get 1 over 4. When the form is more complicated, like number 3, square root of 8x cubed over 50x, it's more easier if we start by simplifying the fraction before reducing the square root. So 8 over 50 can be divisible by 2, gives 4 over 25. X cubed over x, we can simplify the variable to get x squared. So now we have a perfect square in the numerator and in the denominator that gives directly 2x over 5. Again, in number 4, we can start by simplifying the fraction. So 36 over 4 gives 9. A over A5 gives A of 4 to the power of 4. Reducing the square root of 9 gives 3. Square root of A to the power of 4 gives A to the power of 2. Rationalizing a denominator means we need to write the fraction in its denominator form with without radical. So whenever we simplify a fraction and we get in its denominator a non-perfect square number, so we need to rationalize the denominator to remove the radical. How can we do that? To do this, we multiply the numerator and the denominator by the same radical expression. Example, let's say we have radical 3 over radical 7. So this fraction cannot be simplified. We cannot write or give the answer of a fraction with a radical number in its denominator, so we need to remove radical 7. In order to do this, we need to multiply the numerator and the denominator of this fraction by radical 7. Reducing this writing, we get radical 21 over radical 49. As you see, Radical 49 is the perfect square of 7, so we can reduce the fraction in the form of radical 21 over 7, and this is it. This is why we use rationalize, or we do rationalizing for the denominator. And number 2, radical 2 over radical 3. To remove the radical from the denominator, we need to multiply the fraction or the numerator and the denominator by the radical in the lower part in the denominator. So we need to multiply and divide by radical 3. Reducing this expression, we get radical 6 over radical 9. Radical 9 is the perfect, or 9 is a perfect square of 3, so the final answer is radical 6 over 3. After studying the previous slides, please simplify the following radical expressions.